Hello everyone, I am Anand Panchbhai and today at Engineers Classes we are again continuing one topic which we have started last time. It is Gustav Kirchhoff-Hunckel's current law, and today we are having a very nice example in front of us. We have two current sources which are independent current sources, and we have one current source which is a dependent current source, and we will say that it is current controlled current source or current dependent current source just because this current source is depending on the current is flowing in this branch. Is it clear? Is it clear? Fine. So now let's say in KCL what do we do? All the addition of all the currents is equal to 0. Addition of all the currents coming at node is equal to 0. सब अंदर जा रहा है, सब अंदर जा रहा है, सब अंदर जा रहा है. That is equal to 0. So I can say that this current is equal to say I1, say this is I2, this is I3, this is I4. Fine, okay. And we consider at node 1 there is a voltage which is V1. At node 2 we have a voltage which is V2. We are interested to calculate the value of I. This is the question. Fine, okay. What will we do? We'll apply KCL at node 1. So I'll say it's I1 plus I2 plus I3 plus I4. It is equal to 0. Is it clear? Is it clear to all of you? Fine. So we can say this is 4 amperes plus I2 is equal to, this is grounded node, 0 volt. This is V1 volt. Ground. This is ground. This is V1. This is ground. This is V1. So I can say that this current is given as 0 minus V1 divided by 10. Clear to both of you? Fine. Okay. Current is flowing like this. So it is higher potential, it is lower potential. You don't bother. Fine. Right now it is 0 volts. And how it is higher potential? You don't think about it. According to the direction what we people have considered, according to that, this is higher potential, this is lower potential. Is it clear? And that is the reason why current is flowing this way. Plus, what is I3? I3, actually the current flowing in this branch is this 3I. Fine. 3I is current which is flowing in this direction. So according to I3, this is the current what I want. It is minus 3I. So I3 is equal to minus 3I. Is it clear? Fine. Plus I4, it is this current. It's coming from here like this. So V2 minus V1 divided by 2. V2 minus V1 divided by 2. Is it clear to you? Fine. Clear to you? Okay. That is equal to 0. So I can say that this is 4 minus V1 by 10 minus 3I plus V2 by 2 minus V1 by 2 is equal to 0. One equation, 3 unknowns, V1, V2 and I, 3 unknowns. Okay. Let's apply nodal, KCL at node 2. So I'll say that current Ia, current Ia, current Ia and current Ia is equal to 0. Fine. Okay. Okay. So see, sir, it's given that I current is going like this. It's okay. It's okay for me. Fine. I current is going like this. It's fine. Okay. I can consider a direction this way. हमें ऐसा चाहिए कि ऐसी direction हमें चाहिए. We can do that as well. Everything is fine. Okay. You should know what you are doing. So if I consider this direction, I will say that this is I1 dash, I2 dash, I3 dash, I4 dash. Fine. So I can say that at V2, I1 dash plus I2 dash plus I3 dash plus I4 dash is equal to 0. What is I1 dash? It is equal to 3I. Right? Plus, what is I2 dash? 0 minus V2 divided by 5. 0 minus V2 divided by 5. Plus, what is I3 dash? This is actually minus 3 in the book. I'm so sorry, I have not written it correctly. It is minus 3 ampere. Right? Minus 3 like this. And the arrow is this only. What is I3 dash? So it is minus 3 ampere because it is given this way. It is given this way. So it is minus 3 ampere plus I4. I4 is the current. I4 dash is the current which is flowing this way. Matlab it is coming from here like this. Okay, so V1 minus V2 upon 2. So it is V1 minus V2 upon 2, which is equal to 0. So I can say that 3I plus minus V2 by 5 minus 3 plus V1 by 2 minus V2 by 2 is equal to 0. I have got second equation. I have total 2 equations with me. Equation number 1, equation number 2. How many unknowns I have to solve? I have to solve 3 unknowns. Is it clear? Is it possible to do this? No, it's not possible to do it. So what am I supposed to do? I have to replace this I. I have to replace this I in terms of known quantities or some other two variables, that is V1 and V2. पता चला? हमें I को रिप्लेस करना पड़ेगा किसके टर्म्स में? या तो V1 के टर्म में, या तो V2 के टर्म में, या तो इन टर्म्स ऑफ V1 और V2. It is okay with me. Beta, is it clear? Fine. Okay. So now let's say I'll observe the network. I have seen the network. I see, okay, fine. I current is flowing like this. Okay, and I current is flowing like this, so I can say it is flowing from this node to this node. This node is having voltage which is V2, so I can definitely write down I that is equal to I'll write it here, I that is equal to V2 minus 0 upon 5. V2 minus 0 upon 5, so I can say that I is equal to V2 divided by 5. Clear? So I can definitely replace, instead I can replace I as V2 by 5, or I can also do this, V2 it is equal to 5I. So हर एक जगह V2 is replaced with I, so V1 and I, the equation is of V1 and I, and here also equation will be of V1 and I, or else I can replace I, so I'll be having V2 by 5, so this is V2 by 5, this is V2 by 5, so I've got again equations in terms of V1 and V2. Is it clear? Fine. So I'll say that I'll replace this thing, I'll have 4 minus V1 divided by 10 minus 3 into V2 divided by 5 plus V2 divided by 2 minus V1 divided by 2, which is equal to 0. And similarly we can write down 3 into V2 divided by 5 minus V2 divided by 5 minus 3 plus V1 divided by 2 minus V2 divided by 2, which is equal to 0. Now I have two equations, two unknowns. We can solve it. Okay, so let's write down few things here. It's 4 minus V1, this is 1 by 10, I have plus 1 by 2, and let's deal with V2, minus V2 I'll take common, and I'll be having this as 3 by 5 minus 1 upon 2. Is it clear? It is equal to 0. Is it? It is equal to 0. Fine. Anyone is having calculator? Fine. Good. So we have 4 minus V1, this is 0.1 plus 0.5 minus V2, this comes out to be 0.6 minus 0.5, which is equal to 0. So we can say 4 minus 0.6 V1 minus 0.1 V2, it is equal to 0. So I can write down 0.6 V2 plus 0.6 V1 plus 0.1 V2 is equal to 4. So this is my first equation. This is coming in the video, right?
Yes.
Yeah, that's good. So 0.6 V1 plus 0.1 V2 is equal to 4. This is my first equation. Is it clear? Now let's deal with second one. I will have V1 first of all will take. So V1 only one term is there. It's 0.5. Rest of all terms are of V2. So I will say that 0.5 V1, then plus V2 I take common, I will be having 3 by 5 minus 1 by 5, this is minus 1 by 2, that is equal to, minus 3 will come this side, it will become 3. So I can say that it's 0.5 V1 plus V2 into 0.6 plus minus 0.2 minus 0.5 is equal to 3. So I can say that 0.5 V1 plus it is 0.6 minus 0.1, it's minus 0.1, it's minus 0.1, V2 is equal to 3. So I have got another equation. I can solve both the equations I have. Amazing equations, V2 can get cancelled out as well. So let's use elimination method, and in that method let's see, we have 0.6 V1 plus 0.1 V2 is equal to 4. So I can say that this is cancelled out. I'll be having 1.1 V1 is equal to 7. So V1 is equal to 7 divided by 1.1, which comes out to be
6.36.
6.36 volt. And we'll put this value into other equation we'll have. Put it over there. So I'll be having 0.6 multiplied by 6.36 plus 0.1 V2, it is equal to 4. So V2 is equal to 4 minus, what is 0.6 into 6?
0.6 into 6?
6.36. It cannot be 38. It should be 3.33.
2.
have this calculator. Thank you so much.
One.
Keep it. I don't want you to use this mobile. You should be having a calculator. You're an engineer. Fine? Okay. This was 6.36 multiplied by 0.6, which comes out to be 3.816. Fine. Divided by, we have something which is 0.1. So into minus 1 plus 4 divided by 0.1 comes out to be 1.84 volts. So V2 is equal to this. Fine. So V2 I have got, it is equal to 1.84. And if I know V2, I can definitely calculate I. So I is equal to, which is my question, V2 divided by 5, which comes out to be 1.84 divided by 5 is equal to 0.368. So it's 0.368 amperes. So this is my answer. Is it clear? Fine. Start.